Okay, AP Chem, let's review some things about gases. So I'm going to fill these balloons with some gases. Neon is a good solid gas. You guys know what neon is used for. We fill signs with it, we excite those neon gas particles, and they produce a light that is unique. Let's fill this one with O2. Remember, oxygen is one of our diatomic elements, so when I say oxygen gas, I don't mean O, I mean O2, which is also a crucial gas for us to breathe and be here on this planet. My next one I'll fill with argon. A lot of our neon signs are filled with argon also, but it is a noble gas, therefore it is non-reactive. We evacuate light bulbs and fill them with argon so that the metal doesn't chemically combine with the element in there. Argon is non-reactive, so if you fill a light bulb with argon, then the metal can glow without actually being part of a chemical reaction. And then let's fill this one with a super heavy gas, which would be xenon. I've chosen all noble gases except for one, which is oxygen. Oxygen is the most reactive of these these elements. Xenon would be second most reactive. So let's talk about the things that are the same. If the balloons are in the same room, that means the pressure is going to be the same. Let's just pick standard pressure. If they are in the same room, the temperature is also going to be the same. Let's pick room temperature, which is about 25 degrees Celsius. Convert it to K. So the things that are the same is the pressure. The pressure is the same for each one of these. The temperature is the same for each one of these also. Because the temperature is the same, temperature is actually a measure of the average kinetic energy of the molecules. What that means is that not every molecule has exactly the same energy, but if you took the average of the molecules with the lower energy and the average of the molecules with the higher energy, kind of like in a traffic jam, some cars are going a little faster than others, but everybody's going the same average speed. So the average kinetic energy is the same as the temperature. And that's going to be the same for each one of these balloons. So remember we talked about PV equals nRT. So actually, the volume of the balloons is going to be related to the number of moles of gas that we have in the balloon. Once we've wrote that the temperature and the pressure are the same, the formula we would use to compare the volumes would be V1 over N1 equals V2 over N2. So that's what we did in the previous video, that if we have twice as many moles of gas, then the volume will be twice as much. But let's make each of these the same number of moles, and let's just pick 1 mole. If all of these things are the same, then the volume must be the same. The only thing that I don't have at the right STP is the temperature. If it was at STP, the volume of all of the containers, all of the balloons would be the same. The volume would be 22.4 liters. But remember, in AP Chemistry, we are not using 22.4. On the AP exam, please try to resist the urge to use 22.4 because you're going to use it in the wrong spot typically. So let's figure out what the volume is. The volume is going to be nRT over P. In this case, it is 24.5 liters. So here's some things that are all the same. These balloons are the same size, the same volume. That means they have the same number of moles. They're in the same room, so it's the same temperature and the same pressure. The pressure inside the balloon is going to be the same as the pressure outside the balloon. So now we've listed all of the things that are the same in these balloons. Now let's talk about things that are different. The things that are different are obviously the molar mass. So let's pull the molar mass off the periodic table of the elements for each of these gases. The molar mass for neon is 20.18 grams per mole. Oxygen, O2, oxygen gas, is 32 grams per mole. Argon is 39.95 grams per mole. And xenon is 131.3 grams per mole. Now remember our molar mass Kitty formula, which is molar mass is equal to dRT over P. A good kitty puts dirt over P. So if the molar mass is different, but the temperature and the pressure are the same, and obviously R has to be the same, it's constant. So if the molar mass is different, the density must also be different. So we could calculate the density, rearrange our equation. So the molar mass times P over RT is going to give me the density. The density of each of these gases is going to be different. Okay, so when I rearrange my molar mass Kitty formula, I'll get that density is equal to the molar mass times P over RT. So the density of neon is 0.825 grams per liter. The density of oxygen is 1.31 grams per liter. The density of argon is 1.63 grams per liter. And the density of xenon is 5.37 grams per liter. So as expected, the most dense is the gas with the largest molar mass. So the things that are different are the molar mass and the density. The things that are the same are pressure, kinetic energy, moles, and volume. Now let's add one more on there. For those of you who are physics people, you will remember that kinetic energy is equal to 1/2 mv squared. So if the kinetic energy is the same for all of these because we have the same temperature, then the other thing that must be different, because the mass is different, that's molar mass, Therefore, the volume must be different. The velocity must be different also. So this is baby v. Don't make the mistake I just made. Little v is velocity. So that's the speed of the molecules. So the larger the mass, the slower the molecule moves in order to have the same amount of energy. We are not going to calculate the velocity here. It's a little bit, there's a little bit more to talk about, a little bit more calculations. If we have 1 mole of gas, then 1 mole of neon, then the mass is going to be 20.18. You can plug that in and you can solve for the velocity. For our purposes here, though, we don't necessarily need to go into that. That's beyond our scope. What we need to say is that we know that neon travels the fastest in order to have the same energy. So its velocity is the greatest. Xenon is the slowest. So its velocity is the smallest. So I can calculate, but really all I need to do in chemistry class here, that's a little bit more for physics, is to compare them. Neon travels faster than oxygen. Oxygen travels faster than argon. Argon travels faster than xenon. So that's all I need to do is to be able to compare them. So another thing that is different is the velocity. Things that are the same: pressure, temperature, number of moles, volume. Things that are different: molar mass, density, velocity. That's going to take us to another law that we're just going to learn. We're not going to calculate these out, plug and chug, but it's called Graham's law. And Graham's law is a law of effusion and diffusion. We'll learn that in our next video, but basically it is a formula that tells us that larger molecules travel slower at the same temperature and smaller molecules travel faster at the same temperature. So if you think about gases, the gas that moves the most quickly at room temperature would be hydrogen. Gases that would move the slowest would be large gases like xenon. And we'll introduce that in the next video.